Good morning. These are the notes in calculus for section 3.2, which is called the mean value theorem, which is a fairly important theorem, not difficult to show you what it is and not difficult to use, but it's likely to show up for sure on the next test or the AP test. It's just a theorem that you need to be aware of and kind of how to use it and what to do with it. So here's the actual theorem, which I will explain what it says after I read it. It says, and it's often abbreviated MVT for mean value theorem. It says that f is continuous on the closed interval from A to B and differentiable on the open interval from A to B, then there exists a number C in the open interval from A to B such that f prime of C equals f of B minus f of A over B minus A. Let's make some sense of that. The first thing is you'll be asked, like, does the theorem apply? So the function has to be continuous all the way from A to B. Like if there's any asymptote or break in the action, then this theorem does not apply. And it has to be differentiable on the open interval, which means there can't be like a corner, like an absolute value function or a cusp, because that wouldn't be differentiable at that point. There's got to be differentiable everywhere. So as long as that's true, then this says there exists a number C. Notice this theorem doesn't tell you what number that C is. You'll see in a minute here that we are going to calculate that number, but there exists a number C such that f prime of C equals f of B minus f of A. Now let's clarify what each of those sides of the equation are. If you understand what this is saying, it makes perfect sense. F prime of C, well, f prime is a derivative, and when you evaluate a derivative at a point, you're getting the slope of a tangent line. So the left side of this equation, this theorem, is the slope of a tangent line, like at some point in the interval, there's a point where if I do the tangent line, that would be the slope. And then look at this right side, f of B minus f of A over B minus A. You should recognize that formula from years ago. That's just y2 minus y1 over x2 minus x1. That's just the slope, what I'm officially going to call the secant line, which just means from your two endpoints finding the slope. So this theorem says that if it's continuous and differentiable, that whatever the slope, here are your two endpoints. Whatever the slope of that line is, there's an x value in the interval somewhere where the slope of the tangent equals the slope of the secant. So they're parallel. And this picture on the next slide should clarify that. Excuse me. So these things over here are extra. I was just figuring out how to use my dotted lines. So here's some function, f of x, and I have an a and a b. And the thicker blue line in the middle, that's the slope of my secant line. That blue line, the slope would be f of b minus f of a over b minus a. This theorem just says that somewhere in the interval, there happens to be a point C where the slope of the tangent line is parallel to the slope of the secant line. This particular picture, there happen to be two of those, as indicated by those two other dotted lines. Like if I drew something, there wouldn't have to be two. If I drew just a function like that, where my tangent line was that blue line right there, and then here there'd be one point where the slope of the tangent is parallel to the slope of the secant. So you've got to know big picture. That's all the mean value theorem does. It guarantees that somewhere in the interval there's an x value, we're calling this x value C, such that the slope of the secant line, which connects the endpoints, is parallel, and the slope is the same as the slope of the tangent line, which is the f prime of C. So in this assignment, all you'll have to do is this. Sorry. So the question is, what do we do with this process? Here it is. First, it says, find the slope of the secant line. Like, just take your two endpoints, and it might give you y values. You may have to calculate the y value, but either way, calculate two ordered pairs and find me the slope. That's just f of b minus f of a over b minus a. Nothing new about that. That's y2 minus y1 over x2 minus x1. And then find the derivative of the function, f prime of c. We're just calling it c because for some reason that we're solving for c here. It really could be x. We're finding the derivative of the function. Let's say the derivative is 3x squared plus 7x plus 2. That's a derivative. We're going to set that derivative equal to the slope of the secant line. So it's saying if we know what the slope has to be, let's figure out at what x value that occurs. And there could be one, there could be two, there could be more. So your assignment just has several where it asks you to, and I have it on the next screen here. It says determine whether the mean value theorem applies. Like you have to make sure it's continuous and differentiable. Like if there's an asymptote in the interval, or if it's an absolute value function, there wouldn't be one. And if it is, so it says determine whether the MVT applies. If so, find all values of C guaranteed by it. So, and I apologize for writing a slide, but this line here just says, is it continuous on the interval from 0 to 6 and differentiable on the open interval from 0 to 6? Well, this function is a polynomial, and they're continuous and differentiable everywhere. So yes, the mean value theorem applies. So first we find the slope of the secant line, which is right here, f of 6 minus f of 0 over 6 minus 0. And I didn't show my calculations. 2 times 6 cubed is 2 times 216, which is 432 minus 0 over 6 minus 0. So I did that math kind of in my head. I got 72. That turned out to be the slope. So this picture looks like this. 2x cubed looks like this. There's the point 0, 0. Way up here is the point 6, 432. And what we found so far was the slope of, we found the slope of that line, the slope of the secant line, just given the two endpoints. And that was this 72. That's the slope of the secant line. And then all we have to do is take the derivative of the function. The function being 2x cubed, the derivative is 6x squared. And I even wrote x here. I could have written c, either way is fine. And then we're not plugging in 72, we're setting the derivative equal to the slope of the secant line. So 6x squared equals 72, and then we're just solving for x or c. And so I set the derivative equals 72. I divided both sides by 6. I got x squared equals 12. I square rooted it, and I got x equals plus or minus root 12. I simplified root 12. 12 is 4 times 3, and a plus or minus 2 root 3. And if you stop there, you would lose a little bit of credit, because remember, you're looking for values in the specified interval. And the interval for this problem was from 0 to 6. And out of plus or minus 2 root 3, and I don't know what 2 root 3 equals. Let's see, the square root of 12 is between 3 and 4, I guess. But negative 3 point something is not between 0 and 6. So in this particular case, negative 2 root 3 is not in the interval. So the C value that I found guaranteed by the mean value theorem is 2 root 3, which again is like 3 point something. I don't need a decimal. So what did we find here? We'll go back to the picture. There is my picture. So if I were to draw a parallel tangent line, I'll draw it about like that. Let's pretend that's parallel. Let me move this, get this, that's going to get in my way here in a second. So this means that I guess I'll go with blue. I'll go with green. That x value right there is 2 root 3. We found the value, that being x equals 0, and over at the end being x equals 6. We found that the mean value theorem guaranteed us there was a value between 0 and 6. And then we found it by finding the slope of the tangent line. I lied. Finding the slope of the secant line. That was just 72. And then taking the derivative and setting it equal to that slope and solving for c. So that's the process for the mean value theorem. And then your assignment is just, I think there's, maybe 7 or 8. And the instructions are all the same. It says determine whether the mean value theorem can be applied. I think there might be one where you'll realize, hey, I can't even use the mean value theorem, but most of them you can. And then it says to find the values of C guaranteed by the mean value theorem. And the example that I just did was actually, you're doing 35 to 49 odd. I just did number 38, which is one of the ones in that section with the exact same instruction. So that is all I've got for section 3-2. So these first two sections are both pretty short. So have a great Friday. And like I said, we're gonna pick up the pace a little bit. So I would suspect the first 3-1 video will be ready for you guys on Monday morning. Please don't hesitate to reach out if you have questions. Thanks. Have a great day.